Cauchy's mean value theorem. So first we are going to write here statement. Suppose that the function f and g are are continuous on closed interval AB. This is first continuous on closed interval AB, closed and bounded interval AB. Number two, derivable on open interval AB. And number third, g dash of x is not equal to 0 for every x belongs to AB. Then there exists, or I am writing here, there exists a C belongs to open interval AB such that f dash C divided by g dash C is equal to f of B minus f of A divided by g of B minus g of A. So the given statement is given here. F and G are continuous on AB and derivable on AB, open interval AB. G dash x is not equal to 0, and we want to prove this. So given part is given F and G are first continuous on closed interval AB. Number two, derivable on closed interval open interval AB. And number third, g dash of x is not equal to 0 for every x belongs to open interval AB. And we want to prove here that our claim is that we want to prove that f dash C divided by g dash C is equal to f of B minus f of A divided by g of B minus g of A for some C belongs to AB. Some C belongs to open interval AB. Now, so to prove this, now we assume here, now if g of B is equal to g of A, then G satisfy all the condition, then g of x satisfies all the condition of Rolle's theorem. And this implies there exists a C belongs to open interval AB such that g dash of C equal to 0, but which is contradiction that what is given, the given you can check what is given, g dash of x is not equal to 0. So which is contradiction that, and therefore which is contradiction that g dash of C is not equal to 0 for, or g dash of x is not equal to 0 for every x belongs to AB. So okay, why this g dash of C equal to 0? First of all, what is given, G, you can check here, G is continuous on AB, derivable on open interval AB, and if g of B equal to g of A, then g of x satisfy all the condition of Rolle's theorem, and therefore g dash C equal to 0. But which is contradiction that g dash of x is not equal to 0, g dash of x is not equal to 0 for every x belongs to AB. So what this implies, g of B is not equal to g of A. Why we obtain this contradiction? Because here we assume g of B equal to g of A, and therefore This implies g of b is not equal to g of a. Now consider a function. Now we are going to define a new function. Consider a function phi of x is equal to f of x minus a times g of x, where constant and a is chosen such that we select this a such that phi of a is equal to phi of b. Now we define here new function phi of x is equal to f of x minus a g of x. Okay. Now since since f and g continuous on closed bounded interval ab, this implies phi is continuous on AB. Why it is continuous? Because now since f is continuous, g is continuous, and a is a constant, so f minus g is also continuous. Next, number 2, f and g differentiable on open interval AB implies phi is differentiable on open interval AB. Why this is again? Now f is differentiable means what f dash exists, g is differentiable means what g dash exists, and for every x belongs to AB. This implies its phi of x is also exist. So derivative of phi of x is also exist. Number 3, phi of a equal to phi of b. So this function phi of x satisfy all the condition of Rolle's theorem. So this implies phi of x satisfies all the conditions of Rolle's theorem. So and therefore this implies there exists a C belongs to open interval AB such that phi dash of C equal to 0. This is by using Rolle's theorem. So now what is phi of x here? Phi of x is equal to f of x minus a g of x. So now since phi of x is equal to f of x minus a g of x, this implies phi dash of x is equal to f dash x minus a times g dash of x. So here in place of x, if we put here c, then phi dash c equal to 0 implies f dash c minus a times g dash c equal to 0. So here we in place of x we put c. So what this implies, if we simplify this equation, then we get a times g dash c is equal to f dash c if we simplify this. Okay, so but what this implies, a is equal to f dash c minus g dash of c. See, this is equation number 1, or say star. This is equation number star. Now we want to determine the value of f dash c upon g dash c. Okay, now for that here okay, we are going to determine value of f dash c upon g dash c. For that we want to determine value of a. So what is a? What is the condition on a? Here you can see, okay, we select here a. What is the condition on a? Such that phi of a equal to phi of b. This is the condition on a. We select this a such that phi of a equal to phi of b. So since, again I am writing here, now since phi of x is equal to f of x minus a g of x, and since f phi of a equal to phi of b, this implies f of a minus a times g of a and f of b minus a times g of b. So if we simplify this is equal to f of a minus f of b is equal to a g of a minus a g of b, or in others, if we multiply both sides by minus sign, then we get f of b minus f of a is equal to a times g of b minus g of a. g of a. So if we then from this a times g of a times g of a. So we write this a bracket here. So what this a here, a is equal to f of b minus f of a divided by g of b minus g of a. This is the value of a. So if we substitute this value a here in this equation number star, okay, star, to obtain the value of a we use the condition phi of a equal to phi of b. We use this condition. So if we substitute this value here, then we get f dash c divided by g dash c is equal to f of b minus f of a divided by g of b minus g of a. G of a. And hence, what is here c? Where for some c belongs to open interval ab. And this is what Cauchy's mean value theorem.